Increasing evidence shows that biomaterials can provide a wide range of applications in tissue engineering, including the repair of degenerative joint disorders, such as osteoarthritis and gyrolysis. However, the use of biomaterials is still limited because of their low strength and low biocompatible nature. Herein, we report the construction of a biodegradable high-strength supramolecular polymer strengthened hydrogel consisting of cleavable poly-nacryloyl 2-glycine, and methacrylate gelatin, GelMA, Mn2+. This hydrogel exhibits hydrogen bonding to increase its mechanical strength, and in turn, its chemical cross-linking can stabilize the temporary PACG network. Further, a biohybrid gradient hydrogel is fabricated for repair of subchondral defects by a 3D printing technique. Aside from providing support to cell attachment and spreading, the biohybrid gradient hydrogel also facilitates gene expression of chondrogenic-related and osteogenic-related differentiation of human bone marrow stem cells.
This article is titled Osteochondral Regeneration with 3D Printed Biodegradable High-Strength Supramolecular Polymer Reinforced Gelatin Hydrogel Scaffolds and was authored by Fei Gao, Ziyang Su, Qingfei Liang, Haofei Li, Liuqi Peng, Mingming Wu, Xiaoli Zhao, and others.
We are article.tv. Article links can be found in the video description.